Toxicological Research in Little Rock, Arkansas.
Well, good afternoon, everyone. Thanks for being here. I want to thank the organizers for getting the chance to have this session. And I want to introduce you to this concept of using stem cells in a somewhat different way than what we have seen here for the fantastic use as a clinical therapy. What I'm going to talk about today is really the use of stem cells as a model for assessing risk of safety as a predictor of what may happen in the in vivo situation. And to develop such a model, we have to know a lot about what controls the various features and its responsiveness. So I hope to go over some of those things to give you an idea of the complexity of using stem cells in this fashion, but also the great utility of using stem cells in an in vitro setting to help predict the in vivo outcome. Now, in doing so, I want to use anesthetics as an agent, as a test agent. Anesthetics, as you know, have been around for many, many years, are very essential in clinical care. In terms of their use during development, however, that is in children from ages less than 1 all the way up to 15, there has not been a lot of data to indicate their safety. And so what I want to do is just mention to you that in doing a series of studies by our lab and a series of labs across the world over the last 10 years, there's been a question raised about the safety of anesthetics in terms of their use in animal models. We do not know how this may translate to the human condition. I'll say that right up front. But in animal models, there's 5 different species that indicate that exposure to anesthesia during certain stages of development and for a long duration of time will produce dying cells in the nervous system. And in many cases, they've also indicated functional deficits that can occur in those animal models. Again, this has not been translated to human condition at this point. What I want to do is just focus today on 2 particular compounds. That is ketamine, which is an anesthetic that's used in children, it's not used in adults, and on propofol, which is a very short-acting anesthetic that's used in both children and adults. As you can see here, propofol is a GABA agonist and interacts with the GABA A receptor, whereas ketamine is an NMDA antagonist. I want to go through how stem cells respond to these 2 different anesthetic agents and give you some idea about the complexity of that interaction. Over the years, we have studied many different combinations of these agents, including the classical one that's used in many ORs around the world, nitrous oxide, benzodiazepine like midazolam,